Bismillahirrahmanirrahim. My name is Hamza Muzaffar and the topic of my presentation is satellite communications in use. So, starting from the abstract of this paper, satellite communication have recently entered a period of renewed interest motivated by technological advances through private investments and ventures. The aim of this paper is to have a literature review of satellite communication enhancements such as the space-based data collection, new constellation types in satellite communication and its applications such as 5G, integration, space communication and earth observations, and finally future work to discussed. Introducing the paper, all the topics that are covered: satellite communication importance, motivation, applications, system aspects, and then similarly its networking, testbeds and prototyping, open topics, solution. So, satellite communication have found a plethora of applications including media broadcasting, backhauling and gathering, and now it plays an important role in our daily routine. So the motivation behind this satellite communication is the rapid adoption of media streaming instead of media broadcasting and urgent need to extend broadband coverages to undeserved areas. The new constellation types includes LEO and MEO, where LEO are the low Earth orbit constellations that can deliver through high throughput broadband services with low latency. The MEO, MEO, that is medium Earth orbit constellation of 20 satellites have been placed in a circular orbit along the equator at an altitude of 8063 kilometers. The onboard capabilities. The onboard processing capabilities have been the limiting factor for the advanced satellite communication strategies. Recent advances in efficiency of power generation as well as energy efficiency of radio frequency and digital processing components have allowed to enhanced onboard processing, which can enable innovation communication technologies. And next is NTN, the non-terrestrial networks. The main objective of this initiative is to seamlessly integrate these assets into 5G systems by studying their peculiarities in terms of architecture and the air interface. More importantly, the relevant stakeholder would like to enhance unique characteristics of NTN such as wide coverage, multicast capabilities, and its complementarity with local terrestrial infrastructure. Now the new space. New space doesn't refer to a specific technology, but it rather implies a new mentality towards space. It is originated from three main aspects: space privatization, satellite miniaturization, and novel services based on space data. Now coming to its applications, the applications includes the 5G non-terrestrial networks. 5G will be more than just an evaluation of the evolution of the previous standard, embracing a wide new range of applications so as to satisfy future important market segments. And the other and the second application is VLEO and satellite communication aerial networks. The VLEO stands for very low Earth orbit satellites. It is divided according to the operation mode altitudes. So VLEO is very low Earth orbits and high altitude platforms, HAPS, and the labs that are low altitude platforms. So it is the characterization of platforms. The very low Earth orbit platform operate closer to the Earth than LEO satellites. This allows them to be simpler, smaller, and cheaper. Several companies such as SpaceX, etc., are planning to launch their mobile satellite services at VLEO. High altitude platforms, indeed, they are also known as high altitude pseudo satellites. Due to their working altitude, they have potential to provide communication services at regional scale. There are two main ways of cooperating between satellites and HAPS accordingly: backhauling and trunking. The aeronautical and maritime tracking and communication. This application of satellite communication, in addition to the above mentioned use cases, satellites can also play an important role in aeronautical and maritime tracking systems. These systems share many similarities with other kinds of device-to-device communications using IoT. Such similarities are the very low data rates, the sporadic nature of the communications, and the simplicity of the protocols. Earth observation. Traditionally, Earth observation has been used by government or international agencies to report the weather, monitor to the oceans, detect changes in vegetation, and analyze the damage done by natural disasters. So it is also an application of satellite communication, and after that the satellite communication would have been impossible without the efficient communication system between us and our space explorers. System aspects. Some system aspects that are discussed here are constellation types. The constellation types are discussed according to the geostationary satellite. The satellite can cover about the one-third of Earth's surface with the exception of polar regions. This convergence includes more than 99% of world's population and economic activity. The LEO and MEO orbits required more satellites to achieve such global coverage, since non-geo satellites move in relation to the surface of Earth. Hence, high number of satellites must be operating to provide continuous service. Communication architecture. The communication architecture as shown in the diagram is based on space segment that includes the satellite constellations, a ground segment stations, and large ground facilities for control, network operations, and backhauling, and a user segment with the user terminal deployed on fixed and mobile platforms. The link between GW stations and the user terminal via intermediate satellite is named the forward link. The control of the satellite is performed by so-called telemetry tracking command (TT&C). Interface with other systems. To create an interface between satellite and 5G network, different architectures options have been identified within 3GPP studies for NTN. The different architecture options are categorized based on the payload type, such as transparent or regenerative load, and the user access link type, such as direct or indirect. Spectrum. Satellite communications operate in extremely high frequency band, in particular between 1 to 50 Hz. The lower frequency ranges that are represented by capital letters are S, L, X, and C bands, while the high frequencies are KU, K, and then the KA and QV bands. Now the standardization. Thus, the usage of common open standards is fundamental to guarantee interoperability between devices from different manufacturers on both the transmitter and receiver side. This reveals an open market with different manufacturers competing to offer the best possible devices in order to acquire more market shares. So the main set of these standards for satellite communications are DVB, digital video broadcasting, and 5G NTN standardization, etc. Due to the disverification of market, satellite communication need to meet enhanced demand for reliable and flexible connectivity at higher throughput. An interesting hybrid processing paradigm involves digitizing the entire waveform but regenerating only a part of exploitation. Now next is the data collection. The satellite can play an important role in IoT services, more specifically in so-called long-range IoT or low-power wide networks, by ensuring a global connectivity and service continuity. The other interfaces includes also the optimal communication. Here a graph is shown for free space loss and transmission delay for different locations in the solar system with respect to a geosatellites. Here we can say that the delay increases as the distance increases. Medium access control. The aim of this section is to address some fundamental aspects to the medium access control of a satellite. This layer is responsible for controlling channel access mechanisms to enable several terminals or network nodes to communicate in a network. These include MAC protocols for ultra-high throughput satellites, MAC protocols for satellite system coexistence. Here in figure, the architecture is shown where all the protocols are shown working for the satellites. Now coming to the networking topic. The networking aims to cover the main technical advances related to the networking and upper layer integration of satellite communications with 5G network. So it first includes the SDN network function virtualization. The SDN, that stands for software defined network, has principles, separations of data plane resources from control and management functions, centralization, and the programmability of network functionalities. So the SDN parts includes the data plane, control plane, etc. That they are working properly for the satellite communication through a centralized manner. The next is the mobile networks. The mobile networks also have been progressively embracing SDN concepts and technologies to decouple the control plane from the user plane. Then the satellite networks, as they are expected to be an integral part of 5G service deployment, the evolution of satellite technology must also follow the guideline towards more open architecture based on SDN technology. Now the networking also includes caching over satellite. One of the challenges in the edge caching is how to effectively prefetch the popular content into the caches, considering the high volume of data. In order to overcome this issue, satellite backhauling is an promising solution. Testbeds and prototyping. It focuses on communication testbeds which have been developed for different communication layers in order to practically demonstrate some of the advanced satellite communication in concepts. The SDR based multi-stated and adaptive communication systems can be implemented in easily using software defined radio techniques, and it consists in that most of signal processing is performed in digital domain by an appropriate digital signal processing device. The network testbeds. Due to difficult access to satellite systems and its high cost, tools such as satellite systems, simulators, emulators, which in turn have a vital role in the development of testbeds, are becoming increasingly relevant in satellite technology research. Here, SDR infrastructure of end-to-end satellite forward link hardware testbed is also shown. Now the future works and open topics. These are the future work topics that include digital twins for the satellite system, cooperative satellite swarms, hierarchical aerial networks, Internet of Space Things, flying base station, frequency reuse, satellite network automation, advanced satellite resources, orchestration, machine learning applications. And last is the conclusion. So concluding this paper, we have captured the latest technical advances in scientific, industrial and standardization analysis in the domain of satellite communications, the communication testbeds which have been developed, and finally some important future channels and their respective open research topics have been also described. Thank you.